I'm at school in the student development studio where there's lots of lab equipment here, and I brought along with me the Browning Porta-Lamp, my 12 volt 15 watt fluorescent light fixture from 1966, which uses a magnetic preheat ballast paired with a vibrator power supply. I want to test this thing and see what kind of current does it draw at particular voltages, and how low of a voltage can this thing actually run on. So I'm using this bench power supply here, which is good for, I don't know what the maximum voltage is. The maximum current is, I believe, 5 amps. And I've got that. I'm using this Fluke multimeter here to measure the voltage, because I find that the voltmeter on this isn't very accurate. I'll trust the ammeter though. And yeah, right now I've got it tuned for exactly 12 volts. So first, let's see what's the preheat current at 12 volts. About 3 amps. And there we're running. And wow, that's a nice power supply. The voltage is holding steady. Sweet. And at normal running, 1.44 amps, which is about 16 watts and some. Now, what I want to do is start crank the voltage down and see how low I can go before the lamp extinguishes. Now, when I get to the point where the lamp extinguishes, I must act fast and remove power as quickly as possible, because whenever that vibrator's running, without the lamp running, it's quite stressful on the vibrator. A lot of arcing going across it. So let's start cranking it down. We're at 11.9, 1.25 amps, 11.8, 1.20 amps, 11.7, 1.09 amps, 1.6, 1.02 amps. So 11.6 times 1.0, and that's 0.4, it's about 12 watts. Lamp's quite dim. 11.5 volts, still running, and 1.02 amps. 11.4 volts, just shy of an amp. 11.3 volts, still running, 0.9 amps, just over 10 watts. Lamp's pretty dim, it's probably only doing 7 or 8 watts, if that. Keep going down. 11.2 volts, still running. Let's keep going down. We are at 11.1 volts, still running. Lamp's starting to flicker slightly. See if we can make it to 11. The lamp's flickering quite a bit now, a sign that open circuit voltage is starting to reach the minimum required to keep the lamp alive. 11 volts. It's pretty dim. 10.9 volts. Wow, current went down a lot. 0.7 amps. I was interrupted by a classmate of mine that came in. He saw this run in and was asking about it. I explained to him how it worked, the whole vibrator power supply thing. He was quite interested by it. Anyway, where were we? Well, in demonstrating it, I threw it back up to 12 volts. Let's go down to, where were we, 10.9? There's 10.9 volts. So we're doing about 1.1 amps. Let's go down to 10.8. There's 10.8 volts, still running. 1.05 amps. I don't know if that current meter is accurate at all. This power supply is nice. It's got an accurate voltmeter, and I would assume an accurate current meter. But the thing is, I'll crank it up to 12 volts. But as soon as I start preheating it, it goes all the way down to 7 volts. I don't know if there's something wrong with it, or if perhaps there's some limiting setting on there. I don't know. I'm not sure how to use that thing, aside from turning knobs to get the right voltage. So let's go down to 10.7 volts. There's 10.7. Pretty dim. Go down to 10.6. There's 10.6 volts. Let's get down to 10.5, see if we make it. There's 10.5 volts. Getting dimmer and dimmer. We'll also see how low of a voltage we can go and it still preheat and start successfully. So we're at 10.5 volts. Well, it went up a bit. There's 10.5 volts. It's not regulating the voltage very good anymore. Let's go down to... There's 10.4. Jeez, it's just climbing up and up. Get down there. Oh. Okay, I guess that's 10.4. It's getting so dim now that the camera's exposure is going up enough that you can see the surroundings. There's our current, dropped quite a bit. See if we can make it to 10.3. The frequency of the vibrator is dropping. Oh! I think it was rectifying, so I didn't want to keep it running. Let's start it back up. I'm going to bring it up to 12 volts. I'll bring it up to 11 volts or so. There. Alright, let's see if we can get down to 10.3. Oh, stalled again. Yeah, it's not as tolerant now. We're only getting to 10.4 or so before it dies. We'll see if it'll start at 10.8 volts. Yeah, no problem. I'll crank it up to say 13 or so to let the lamp kind of stabilize. There, 13.5 volts, nice and bright. I'll let you listen to how the vibrator's frequency fluctuates as I turn down the voltage. Alright, we're at 10.5 volts. Oh, see, it starts rectifying before it actually goes out. We'll see if we can start it at 10.5 volts. Yeah. Oh, it died. Oh, yeah, it's kind of hard to tell if it's running normally or if it's rectifying. It's kind of funny because when you're at kind of a low voltage, when you preheat the lamp and let go, it starts fine. And then it starts to get dim as if it's going to extinguish, and then it brightens back up. See, we're at 10.8 volts, and if I start it here, it's bright, and now it's getting dim, and there it went bright again. It's kind of funny. It kind of puts you on the edge, is it going to stay running or not? That's weird, it was able to get down to 10.4 volts before extinguishing, but now it can barely get past 10.5. There's 10.56. Oh, and it's going to die. Crank the voltage back up. It's probably bad for the vibrator if it's rectifying too. I really should just cut voltage off as soon as I see it start to not run fully. 10.6. 10.54. Yeah, it ain't having it. I think the best we got before was 10.3, but now it doesn't really get past 10.6. I discovered why this power supply was acting weird. It actually limits itself to 2 amps. That's the maximum current it can pull. So anything that tries to draw over 2 amps, it lowers the voltage so that it only draws 2 amps. So when I preheat, voltage goes down to like 9 volts, because at that point it draws 2 amps, but then when it starts, then it kicks itself back up to 12 volts, because it's within the 2 amp limit. Only other problem is this power supply is really loud. But let's turn the voltage down on this and see at what point it dies. We are at 11 volts. There's our current. $10.7. $10.6. $10.5. Oh, I think it's starting to die. Oh yeah, it's dying. Okay, it's running again. 10.7. We can actually use the current as an indicator of when the lamp starts to extinguish. 10.6. $10.5. Oh, and there it goes. Off, off, off. So at 10.7 volts, at that current, it's doing just under 7 watts. So the lamp's probably only doing 5 or 6 watts, very underdriven. The lamp wouldn't last very long running like this. Good thing we're just using a junk lamp for these experiments. Well, after much fiddling with knobs, it would appear that the absolute lowest voltage that this thing can run stably at least with this particular lamp, is 10.8 volts. Now let's see how low of a voltage it can successfully start and stay running at. We'll start with 10.7. Really, this shouldn't work because it can't even keep running stably at this voltage, but let's see. Preheat current is that. And it dies. Let's try that one more time. Nope. Alright, now we're at 10.8 volts or thereabouts. There's the preheat current. Nope. Let's try it one more time. Nope. Alright, let's try 10.9 volts. There's current. Oh, it's so close. Yeah, I think it's rectifying. I'll do that one more time. Yeah, I think it's running stably. Yeah, 10.9 volts seems to be able to start and stay running. We'll do that one more time. Alright, it gets in that phase where it gets really dim and then brightens back up. Well, I've done all the tests, which basically consisted of twiddling knobs and starting the fixture over and over and over every time the lamp died out. Here's the final verdict. The lamp can run and the lamp can start at as low as 10.8 volts. However, there are some situations if the lamp simply becomes stubborn because it's been underdriven, like this lamp has been pretty much the whole test, that it'll become a bit stubborn and it might not start or run reliably at as high of a voltage as 11.1 volts. So my final verdict would be, for the Browning Porta-Lamp, your absolute bottom voltage that it could function at would be 11 volts. But maybe someday I'll try it with another lamp, a more stubborn lamp, that maybe requires even higher voltages, and I will revise that statement. But here it is running nicely at 12 volts. I figure I've tortured it enough. I've been at this for an hour now. What time is it? 8:30. You know, hour and a half now. I've been torturing this thing, running these tests, but it is in the name of science. So I'll put it back in its box and I'll head home and let it rest once again. Alright, hope you guys enjoyed, and thanks for watching.